Next one we have insufficient logging and monitoring. It is a common vulnerability in API that exposes system to various cyber threats. It refers to the absence of lack of proper logging and monitoring practices that allow malicious actors to infiltrate and exploit system weaknesses without being detected. We will discuss the insufficient logging and monitoring vulnerability in API and its potential impact on an organization. Insufficient logging and monitoring refers to the absence of proper logging and monitoring practices in an organization's API. When an API is not properly monitored, it becomes difficult to detect and respond to security incidents in real time. This makes it easier for attackers to launch attacks on the system and cause damage. The insufficient logging and monitoring vulnerability in API can have significant impact on the organization. The lack of proper logging and monitoring practice can make it difficult to detect and respond to security incidents, which can lead to data breach and loss of sensitive information. Attackers could exploit this vulnerability to gain unauthorized access to the system and steal confidential data, install malware, or cause damage to other organizations. For example, a hacker can launch a brute force attack on the API to gain access to the system. With insufficient logging and monitoring practices in place, the organization may not even realize that an attack has occurred until it is too late. By the time the organization becomes aware of the breach, sensitive data may have already been compromised. To prevent the insufficient logging and monitoring vulnerability in API, organizations should implement the following measures. Logging. The organization should implement logging practices that capture all API transactions, including the source IP address, timestamp, and request response data. This will enable the organization to detect and investigate any suspicious activity. The organization should implement monitoring practices that enable real-time detection and response to security incidents. This includes setting up alerts for any suspicious activity and implementing a security incident response plan. The organization should regularly test its API for vulnerabilities and weaknesses. This includes both automated and manual testing to identify any potential security flaws and fix them before they can be exploited. Security policies. The organization should implement and enforce security policies that cover API usage, access control, and authentication. This includes restricting access to APIs to authorized users and implementing secure authentication methods, such as multi factor authentication. Insufficient logging and monitoring is a significant vulnerability in API that can expose organizations to various security threats. To prevent this vulnerability, organizations should implement proper logging and monitoring practices, regularly test their API for vulnerabilities, and enforce security policies that cover API usage, access control, and authentication. By implementing these measures, organizations can protect themselves from potential security breaches and safeguard their sensitive information. So here we have an code deck is a cloud-based code repository and issue tracking platform used by startups, companies, and independent developers to host, collaborate, and control the version software repositories. Further, CodeTech has recently launched an API service, Code API, which allows programmers to integrate code doc functionality into their existing projects and applications. Alice, a registered user of CodeDoc, decides to use the newly launched Code API service to build a web-based dashboard for tracking her team's project and development progress. To access and configure Code's API, she starts by logging into her Codec account with the following credentials. Having logged into the Code takes Alice browser to her account page where she can access and configure the Code API services. Codex API provides a variety of REST API to retrieve project data, reporting metrics, and project statistics, allowing developers to integrate code dog reporting and analytics within third-party applications. To securely access CodeDoc's REST API, a private access token, that is API token, must be passed by a private token header, which defines the private key to access the API. To demonstrate the risk of insufficient login and lack of monitoring in application, let's first open a terminal and monitor the CodeDOS application log file by issuing the following command. As Alice, access the code API endpoint at the following C URL passing your private token as a request header. C URL, that is curl, is a command line tool for generating HTTP request. So as Alice, issue the above curl command to access the code API endpoint. Interesting, although Alice ran the curl command against Kotak API, the server side didn't log any information related to this access event. Although the lack of event logging for Alice API requests may not appear to be significant security risk, let's assume a scenario where Alice API gets leaked, stolen, or misused by an attacker. In such instances, the lack of traceability to reconstruct an attacker's action may prevent Code security and incident response team to successfully identify a potential security breach and further carry out the root cause analysis of a security incident. To further understand the root cause of insufficient logging, let's review the source code used for CodeDoc's API controller. CodeDoc's developer implement the get project method, which is used for retrieving the list of projects. First, it extracts the private token header and then validates it. If the token is valid, the method returns the list of projects. However, notice that no logging is done for this API endpoint, so the developers cannot track any suspicious activity related to this endpoint. In order to effectively mitigate against insufficient logging and monitoring issues, developers must follow the following logging best practices. Ensure all login access control failures and server-side input validation failure can be logged without sufficient user context to identify suspicious or malicious accounts and held for sufficient time to allow delayed forensic analysis. Ensure that logs are generated in a format that can be easily consumed by centralized log management solutions. Ensure that sensitive actions have an audit trail with the integrity controls to prevent tampering or data deletion, such as append-only database tables or similar. Establish effective monitoring and alerting such that suspicious activities are detected and responded to in a timely fashion. In order to implement adequate logging, the developer leveraged the capabilities of Java string interceptors. The long logging interceptor is called on every HTTP request. First, it extracts some variable data from the request such as timestamp, HTTP method, URL, IP address of the client, etc. Then it logs the aforementioned data, which allows the developer to track the access to the API and catch suspicious activity in time. So having gone through the code fix, let's try accessing the code API endpoint once again by issuing the following curl command to see whether CodeDocs backend is recording log events with the updated code fix. Success with the updated code phrase. Alice access to CodeDocs API successfully creates the relevant event information, including the request timestamp, HTTP method, URL, and the IP address of the client. Now, if something suspicious happens, such as DDoS attack, the developer will be able to identify the source of the attack via the IP address, retrieve from log, and react accordingly.